Hello everyone. So welcome to this talk titled Java Migrating to Java 11 in Real App. My name is Piotr Przybyl and we are a DevOps app. And yeah, I guess this thing you're asking yourself when you enter the room, I mean, you have many questions about Java 9, 10 and 11, but the question you have, like when you were reading the agenda is, what the heck is this guy's name, right? So in Germany I'm called or nicknamed Piotr ohne Vokale, which means the vowelless Piotr. And apparently in Polish this is E and this is Y, I mean the Greek I. So I have two vowels and this reads as Przybyl. So I'm not that much vowelless. Anyway, here's my email address, here's my Twitter account, so you can send your comments, feedback, hate, whatever. And I self-employed as remote freelance software gardener. If you have attended one of the talks, great talks of Victor yesterday, you know already who software gardener is. And remote freelance means that when I awake, I need to take second door to the left to get to my working place. I also work as a trainer on Java, Scala, clean code and refactorization for a few companies, one of them being Semanthis. Okay, I'm doing Java for quite a few years. Actually, I've been doing Java since Java 1.3 and backporting to Java 1.2. And one thing I need to tell you, really, migration from 8 to 11 is not the most difficult one I experienced myself. And I'm so much hardcore Java guy that even when I go on holiday to Spain, Java haunts me. Like it's behind my back, so I, better be prepared, basically. We did this little voting before we came online, so I already know who you are. You're mostly Java developers who would like to migrate to Java 11 if the boss finally permitted to. Okay, so a little agenda for today. What are we going to talk about? We are going to talk about crucial non-technical changes. We're going to cover removed and deprecated stuff. And basically this talk is about how to run your application on Java 11. Not how to rewrite it to Java 11, but how to run it on Java 11, provided it was working on JVM/JDK 8. And also what's not covered in today's agenda, it's all the new stuff. So if you want to come out of this room like after 50 minutes and know everything, what's new and noteworthy in Java 11, sorry, it's not this talk. So it's only about running the stuff we already have. I'm not sure the stuff is the best description, but anyway. Okay, so there's this debate, Oracle JDK versus OpenJDK. Who has heard of OpenJDK? Raise your hand, please. Wow, that's an impressive audience. I like you. So both are released or maintained or owned or whatever we call it by Oracle Corporation, right? And in terms of technical aspects, they're mostly equal. I mean, there are some corner cases, I mean, the sharp edges or something when they are not equal, but if you're just developing standard Java applications, I mean, Java SE, the scope, they are most probably equal, like 99, something%. However, there are some differences. The first obvious one is the name, but of course there are also other differences. One of them is the license, as you know, because the open implies that it's like open source or maybe free, whereas Oracle is not. So of course there are differences when it comes to releasing cycle, cadence, payment, money, licenses and stuff. So in these terms they're not equal, of course. So there's this new release schema in case you skipped all these presentations which were given like a few years ago. There's new major release every 6 months, and it's not postponed by the features, meaning if a feature doesn't make it, simply it doesn't get merged into the next major Java release, basically. So we are not observing, and we shouldn't observe anymore these major versions of Java being postponed more and more because like there's certain features still that needs to be worked on. And as for Oracle JDK, Oracle promised to give us something called long-time support release every 3 years, meaning Java 11 was, or is still, of course, long-time support. Java 17 will be then 23 and so on and so on. And this is, of course, for Oracle JDK, mind you, here. And as far as I can tell, they got pretty much influenced by Canonical, Ubuntu, and the stuff. So they don't want to support every possible version for that long because this, if they wanted to make every version LTS and support it for 3 years, then in 3 years' time they would have to support 6 versions of Java. That would be challenging. And this also means instant lack of support for the previous version of Java for OpenJDK, basically. So you can't even switch to the previous one using this version :release as we used to do sometimes in the future. Sorry, in the past. And now there's this little, or maybe not little, actually it's huge. I mean, this is huge. This is the huge slide from Azul, from Simon Ritter, and this shows us all these versions of JDKs coming from Oracle. So if you're a bit colorblind, these gray boxes mean public build, meaning more or less OpenJDK. Then this pinkish color is Oracle's commercial support, and this very almost red, or maybe it's red, sorry, it's extended commercial support. I guess it means more money. Anyway, we then have these new versions of Java released every 6 months, and the gray boxes mean that you have this free version of Java, and this is this extended version of Java, like here and here also Java 8. And this brings us to this nice triangle, meaning our JVM can be secure, free, or stable. And we have to pick two. If, like me, you always pick the secure corner, then this leaves us one more option to choose, meaning you can either be stable, meaning you don't have to upgrade every 6 months, but then it's not free, you have to pay, or you're going for the free version, and then you have to challenge this support cliff, meaning you have to upgrade every 6 months, every half a year. But there's one thing I'd like to highlight, literally, is that it says Oracle, Oracle, and Oracle. That's important in this slide. I mean, it's up at the bottom, but I think it's one of the most important things in this slide. So remember, there are also other JVMs and other vendors. Like, let's say you can take a look at this, like for example, SDK list Java, and see there are many, if it works, yeah, there are many versions of Java vendors, like Amazon, Azure, Adobe OpenJDK, also, yeah, Graal, SAP, also this Red Hat or IBM, they are not listed here. And yeah, so you can repeat after me, because there's this constant debate, like people saying, like when they enter my trainings, but we are not going to migrate to Java 11 anyway because it's paid. You know, it's paid, so we're not going to do that. And this brings us to these discussions. You know, people keep saying that the Earth is flat. Some people, usually the same, keep saying that you should be wearing a tinfoil hat to protect yourself from the cosmic radiation. And they also write this, excuse my French, crap in various forums that Java 11 is paid and therefore you cannot migrate. It's not the case, my friends. Java 11 is not paid. I mean, there's Oracle JDK, which is paid in production, and there's Java, which is not paid. So you can repeat after me. Java 11 is not paid. Come on. Java is not. You know, I think your boss didn't hear that. Okay, let's be louder. Java 11 is not paid. Once more, Java 11 is not paid. Exactly. So stop saying that Java 11 is paid, stop saying that the Earth is flat, and stop wearing one of these, you know? It really makes you stupid, basically. Okay, Java is still free, Java is still GPL v2, so we can refer to this link, of course. And if you're like wondering which version you should choose, you can always go to Adopt OpenJDK, which acts more or less like this. Once Oracle kind of abandons or stops supporting certain version of OpenJDK, then this umbrella or / consortium or whatever, they take care of this, of maintaining this abandoned or no more supported version, and they simply backport the bug fixes and stuff, meaning you can still enjoy a free version of Java 11 as if it was LTS, basically. So you can go to Adopt OpenJDK page, you can select the version you prefer, hopefully not Java 8 like in this slide, and then you can also select, you can either go for Docker, you can select various operating systems, or you can go for Windows if you really have to. Okay, so who recognizes this slogan? Yeah, exactly. This was the great promise in the Sun times, right? And actually, I mean, when you had your hands dirty with code, just like I did, we knew it worked this time, back in times, right? This was the actual true, right? Once debug everywhere, basically. And yeah, so there's when it comes to migrating to Java 9 and above, there's this kind of distilled statement which says that normal Java SE applications should just work. And it has two caveats, my friends. First, it's normal. Is your application normal or not? Who can tell? right? That's one thing. The other, it's should. That's why I even highlighted this. It's should. It's like it will work, it's guaranteed or something. It says it should work, okay? So meaning we cannot tell if it works for granted. And I mentioned 2 caveats, so of course there has to be a third one, which is this standard edition. So if your application is a bit more enterprisey or EE, it cannot be. It means it might not be covered by this sentence at all, basically. Therefore, like we can read this statement again in a human language that in all other cases this migration might not be a simple and single step, basically. That's why you're here, I guess, and that's cool. Actually, there are more steps than just one. So yeah, you have to convince the business. You have to convince the boss, right? Someone has to give them money, right? And like budget and time and whatever. So here are the reasons to convince your bosses or the dragons that keep our gold treasures. I use them and they worked, and here they are for you also to share. So Java Flight Recorder and Java Mission Control. Now you don't have to do this unlock commercial features without paying for license. Now Java Flight Recorder is released since Java 11 for free, and it acts like a flight recorder. So in a plane, when a plane flies, a real plane, I mean, you have this concept of a black box recording various parameters of the flight of the machine and so on. And actually, it's orange, by the way. And once something happens to the plane, sometimes unfortunately things happen to planes, then the specialists extract this black box and analyze the content inside to discover the reason what failed, basically. And this is the same principle here. So the Java Flight Recorder records stuff to this flight recorder, basically to this black box, and then we can analyze this black box using Java Mission Control. So it's extremely cool, nice, very handy, low overhead production profiling, I would say. It's unfortunately it's still not real time or near real time because it's offline. But in Java 14 we might see it being almost real time. String has array of bytes inside, meaning we have compact strings. That's why many companies didn't wait for Java 11, they jumped to Java 9 instantly. Because, I mean, this was the famous question asked by recruiters, right? What's the encoding of strings in Java? What's the encoding of strings in Java? Who said that? Okay, you got jellies. Pass it there, okay? This was true. Up to Java 8, from Java 11, from Java 9, we have bytes, not characters stored inside the string. Meaning, if your character happens to contain all the characters which are covered by ISO Latin 1 range, then we're not wasting every single byte to keep zeros. So there's one more byte flag saying being coder. Okay, I can show you that. We're developers, right? In code we trust. So let's go here. Let me open, please, the string class. Yeah, so we have string class, and see it has the array of bytes, and there's this new file called coda. And if this says like when it's ISO Latin 1, then we skip the zeros. And if you have like non-Latin characters, then it's going to be UTF-16, like in a good old times, basically. So like in our case, our application was mangling for a first minute 24 gigs of data in general on a heap. And it happened that after switching to Java 11, we saved out of this 24, 4 gigs, if I remember. That's 1/6, like 16% for nothing, just for switching to the higher version. I mean, so we have like less memory occupation and fewer GC cycles, basically. Application class data sharing, which I use to speed up your boot up time of our applications, basically. I covered that more in details on Monday. That's why, if you don't mind, I'll skip it. I mean, we've benchmarked that on Monday, so I refer that. And there's a link in the slide if you're eager for more explanation. And there's also better integration with containers. Since Java 10, Java is more aware, for example, of these restrictions we have put on the Docker in production, like meaning if you have said that the Docker should use just 2 cores, not all of them, Java 8 inside will have troubles with recognizing it, meaning it can have like a larger fork and join pool and stuff, whereas since Java 10, it got improved, like Java is aware of these limitations. Okay, so there are also other big changes, in my opinion. You might not agree, but it's like biased. So there's Java Unified Logging, which allows us to log everything which is internal to Java in one unified way. I mean, there's one switch, -x log, and you can log everything. I mean, class loading, garbage collecting, everything. I mean, what's happening under the hood? It's like no dozen switches or tens of switches anymore. Of course, there's this huge change of Java platform module system / Jigsaw, and there's the huge change of JShell. There's also var, which I mean, it's being repeated, and still I think they didn't catch, so it's not a new keyword. It's more of a type indication. So I'll show you both JShell and var. So we can go JShell, and then we can do var equals I hate my coworkers, which is not actually true, but if you name your variables like this, you clearly hate your coworkers, right? So yeah, please don't do that, but still you can benefit from this, and we can like var get class, so we know it's string, so we finally have a REPL in our beautiful Java we love. And maybe I'll be able to show you that we can finally write scripts in Java. So we have kind of concept of this Java script in Java. And what I think is, I mean, it's last but not least, finally, the guys roaming in this conference are removing stuff from Java. I mean, these balls and chains which prevented us, and moreover the JDK from moving faster, to be more agile and to be, like developed faster and better and so on and so on. So like removing stuff from summits and save and so on and so on. From my point of view, it's cool. I can only ask, why so late? So let's talk about this removed stuff. So here we have this nice module which would read like standard edition.enterprise edition. Funny name anyway. It got decoupled, so it's not removed. It got removed in Java 11. It's no more shipped with JDK. Also Corba. Who's running Corba? Yeah, I mean, okay, I have jellies for you. Really? Can you pass it to the guy over there? Sorry. Oh, I throw. Yeah, sorry. These are jellies, not candies, so they won't harm. I had Corba too. So bad news, Corba got removed. Yeah, wave your hand so they will get you. Yeah. And JavaFX got decoupled. I mean, at least from OpenJDK. Applets are no more. Who loved applets? I loved applets. They're no more. Yeah, we're in deep trouble. Java Web Start also got removed. Many XX parameters. This might be the moment where your DevOps friends from your company will start crying, because there was almost like 800 parameters for Java 8. Now there's like 500 something. So if they were really using some fancy parameters, mostly outdated or deprecated, they have to redo their scripts basically, and we have to help them. So we can show them the bloody manual so they can read that, right? And various sunmiscan-save methods also got removed. Another time. Who's using sunmiscan-save? Yeah, you were the first one, yeah. Jellies. He's an honest man, really. He's an honest man, and he's very fast. Okay, let me rephrase this question. Who's using Spring? Keep your hands up. Who's using Hibernate? You people are using sunmiscan-save, most probably. Now you know. Now you know. Okay, so of course there's more to this removed stuff. So there are lists of stuff that got removed in Java 9, 10, and 11. I highly recommend you should RTFM these, basically. And let's talk about the deprecated stuff. There is a new concept when it comes to deprecation. It's called the enhanced deprecation. And do you recognize this annotation? Yeah, it's a new one. Exactly, that's why you might not recognize it. First, it starts with a big D, with capital D, not the small one. It's a big decimal, big thing, mind you. And it has this parameter called for removal, which might be set to true. And what does it mean in short? Whatever you spot in your code, that you're referring to parts of API, like methods or classes or whatever, and these pieces of API you're referring to are annotated like this, big, deprecated. For removal, it means that in the next major version of Java, they might be gone. Because the previous, lowercase deprecation, deprecated meant more or less like, maybe it's bad, or maybe they will remove it. I call it Heisen annotation. You wouldn't know until the next release. Now we know you can't rely on this. Whatever is so deprecated for removal set to true, it means in the next version it might be wiped out. And if you want to find out, because let's say you disabled compiler warnings, I mean, yeah, many people do that, unfortunately, or you just get your dependencies as jars, then you can JDep scan your class path, and it will tell you that you're using these pieces of deprecated APIs, so you don't get shocked in the next version. And concurrent mark script got deprecated, and most probably it's going to be removed in Java 14, maybe 15, we'll see. Nashorn got deprecated after being upgraded. Okay, and in my opinion, also the deep reflection got deprecated. Who knows what deep reflection is? Jealous. Okay, the difference between shallow reflection and deep reflection is more like this. Shallow reflection is... Sorry, I almost made it. Shallow reflection happens when you just call stuff by name. But let's say you want to instantiate a public class or call a public method. This is called shallow reflection. But when you summon the demons of the deep reflection from the deep, deep hell, just by calling this method set accessible true, you're committing the crime of deep reflection. Meaning you're violating OOP principles because you want to misbehave. Right? Somebody made this field of the method private, most probably for a reason, right? So this is a deep reflection, basically, and yeah, it's related to illegal access, and in my opinion, they want to clean this stuff up, basically, but just my reading. Okay, let's talk short about the modules. So Jigsaw, so modules got everywhere. Or not. I mean, JDK got modularized, and it's no question about it. So it's already modular. If you attended this session, like Ask the Architect, there was also this question, what's the status of modules, like are they getting adapted or not? Yeah, they're getting more and more adapted, and the change should be like this. First, the libraries should get adapted, then our applications. Of course, so it's happening. Well, it will happen to the very end. I very much like the quote from Professor Horstman, who wrote more or less that modules are kind of social experiment, and we're going to see if they're going to catch or not. And why they introduced modules? Well, several aspects. First, I think they wanted to get rid of this bloody jar hell. So basically, we had these three applications, all of them using the same jar, let's say Apache Commons in a given version. And then was this really smart administrator managing this Tomcat /JBoss / whatever, who said, hey, they have the same version of this jar, or they have the same jar, what not to extract it from their class paths and put it directly into container, like Tomcat, for example, right? And then you upgraded because you wanted to have a new version of Apache Commons, for example, because they had a new method, and then it works for all the productions like your demo, then pre-prod, staging, whatever, and then it doesn't work at the production because it says that there's no such method. And there is no such method because Tomcat first is reading its own libs directory, right, and not your own. And this doesn't happen with module path, basically, but because with modules the rule is simple. One package can belong to one module, and one module means one jar, basically. So there's no jar hell anymore. And it's also about better encapsulation, because we know this, we are taught at the university or bootcamp or whatever, there's this private, protected, public, and the default access, right? And these were cool, and these are still cool. If your application is like 200 classes, like the applets we had in Netscape Communicator. But now we have these huge behemoths, these micro monoliths and whatever, and you have this .impl package, and you have public classes in there, and you want the colleagues, I mean the friends from the other team not to call them because these classes are public, because you have to test them, of course, and it makes some testing easier, yet you don't want them to call it because it's not your public API. And there is where modules come into action, because you can make these public types from a given package not exported to other modules, basically. So it's about better encapsulation at the architectural level. So it's about getting us slowly and slowly from class path to module path. And you can repeat after me if you wish, but you don't have to, because there's also this common fallacy that, we would love to migrate to Java 11, but we're not going to rewrite our application to be modularized. You know what? You don't have to have modules to run Java 11, basically. I mean, you can, but you don't have to. Really. So please tell your friends to stop saying that they won't modularize their application. That's why they're not going to migrate to Java 11. Okay, but remember the JDK is modular. There is no more RTJAR. I can even show you that. See, let's switch to the terminal. I have JDK. Sorry, it was in the other ones. I have various versions of Java installed. You see 8, 9, 13, yeah. And then let's find for the RTJAR and see it's present only for these versions of Java 8, basically. So Java 9 and onwards don't have this huge rt.jar because Java is modular now. Java itself, I mean. Okay, so there are migration steps. You want to migrate. You have your nice application, and you want to make it run not on JDK/JVM8, but you want to make it run on Java 11, right? So first, I really suggest you should install SDK Manager because yeah, I can show that why it's cool. See, I have here Java version. In this tab, I have Java 8, and then I switch to the other tab. I have Java version 11. So you can run 2 versions or many versions. I mean, in each tab you can have a new version and then compare the behavior to see, why tests are passing, aren't passing, and so on. It's so cool, really. I recommend that. Then, of course, you have to upgrade your IDE because having a version which I know so dinosaurs might not work when it comes to migrating to Java 11. Then you have to upgrade your build tools, meaning Maven, Gradle. They need to be aware of given version, and you have to upgrade your continuous integration, like Jenkins, TeamCity, whatever you use, because they also might not be aware of certain aspects. And if you still have containers like Tomcat, JBoss, who has still JBoss in production? Yeah, okay. So maybe you have bigger issues when it comes to migrating to 11. Nevertheless, okay. Of course, and this would be like usual habit, but let's say it's a legacy project, so till it works, don't touch it. But if you want to run it on Java 11, it might be that you need to upgrade the dependencies because some of the libraries are calling pieces of API which are gone. For example, some methods from some is unsafe, right? That's why you have to upgrade the dependencies in POM or Gradle file, basically. Sorry. So finally, you can compile setting 8 as a target version and try running as 11 and maybe as Java 9 or 10. Who has imports starting like Java X in their code? Raise your hands. Yeah, so I had them as well. So for us, it might be a bit easier not to jump directly to 11, but for like local migration to do it with Java 9 or 10 first, because not to make a huge jump, but in little steps, basically. And we need to add explicit dependencies for all these modules which got extracted, like JAX-B, like web services and stuff, basically. I'll show you that in a minute. Then, yeah, really, I couldn't agree more with Victor yesterday. Then you should test it and automate like crazy in each step. Because what happened to one of the migrations I did? Like, it didn't compile. Okay, so I updated the code and dependencies so it started to compile. Okay, then the tests were passing. Okay, cool, so let's ship to the production. It went to the production. And then only 3 invoices didn't get generated. So we had a quick rollback, but we have everything scripted, like automated. I mean, we have continuous delivery and continuous undelivery. Let me put it that way. So we had to generate these 3 invoices manually. So then there was a time for like a real test of covering all the paths. And turned out that we had some paths of our application not covered. So now, if you're going to migrate to newer versions like 12, 13, or maybe 17 in the future, it's pointless to do these tests manually again. It's better to automate this, right? Basically, that's why you should automate like crazy. And there might be extra migration steps. If your clients/customers are still running your stuff on premise, they might be using Java 8. So it might be that you compile using Java 11 and still release bytecode for Java 8. basically, for them. Yeah, you can play with this illegal access debug/deny, and you can need you might need these options just to make Java not complain about these. Yeah, so in general, two things may happen. First thing, you will face compilation errors like missing class, missing method. Then there are runtime errors. Again, something like casting, like, again, method not found or whatever. And of course, we need to have the third one, which is this illegal access. It's not strictly an error, but it may cause some people freak out because, hey, it's illegal access when I run your application, right? So if you have missing applet.corba, sorry, folks, you have to, yeah, just either not migrate or just, you know, do something about this. If you have something from JavaX, I really recommend this brilliant post on Stack Overflow from a new Java champion, Nikolai Padlog. Then you have missing classes or methods. Then I guess you didn't upgrade your stuff, your dependencies, basically. If you have any missing XX parameters, you should RTFM and upgrade the script. And when illegal access happens, I mean, when you summon the demons of the deep reflection, like certain libraries scanning, like internals, I don't know, for dependency injection, or entities for JPA and stuff, then illegal access happens. So what you should do in the first place, yeah, Java will complain because Java is modular now. What you should do in the first place, you might need all these 5, but like, should I have, yeah, this thing. Like, I'm really glad for Sergey Yegorov. He tweeted this a few days ago. Yeah, and I mean, this short video describes what happens when you abuse reflection. You like using deep reflection. And let me play it for you. I really like it. Yeah. So this, Serежа, еще раз спасибо большое. This is what happens when you don't use stuff correctly and instead you want to use it using reflection, basically. So these are the needed 5 to like stop Java to complain about illegal access and stuff. Most important among these is, yeah, and before we dive into them, is just everything you have on your class path ends up as one huge module called unnamed module, yeah, from Java 9 onwards. So you don't have modules, but JVM is modular itself, and everything you have on your class path is de facto one huge, all unnamed module. So we need to use them in the switches like this, for example. So when you open a certain package from a given module to everything you have on a class path, you need to add it to your Java command, basically. Also, then if you want to say that certain module can read something from the other, then there's add exports. If you want to add some extra modules, let's say something for encryption, or for Java 8 or, sorry, 9 or 10, you want to enable this XML stuff, then you have to add these as well. And add read, sorry, I'm skipping a little bit because I want to show you the code when we'll use it, because in code we trust, right? And if you end up having too many options like this, like 50 for single library and 70 for another one, and you don't want to have all of them listed like in Maven or like in a bash script or whatever, you can set them in a simple flat text file, and you can change these text files basically. One thing you can't do, you can't nest them. That's important thing remember. There's one thing, because I wanted to explain to you this illegal access. Yeah, so this is it, sorry. Somehow the clicker doesn't work with these slides. So there are 4 modes when it comes to illegal access and Java reporting the illegal access, like during the runtime. So this is the default one. This is called permit, and I call it, like, from my point of view, it is a friendly option. It will tell you just once, okay, look, my friend, you have an illegal access somewhere in your code, and that's pretty much it, right? And yeah, and then we can go for this other option, which is warn, and I call it myself the wife option. Because it will tell you every time. I mean, every time it will complain, look, you have illegal access, look, you have illegal, can't you see you have illegal access? Okay, so it's a wife/husband option, okay? Then there's another option, I call it mother-in-law option. It behaves just as your partner, only it's very precise. See, here you have this illegal access, and here you have this illegal access. Fix it. And then there's one more option, I call it the father-in-law option. It behaves just as mother-in-law, except you can commit this crime only once. And then you know the story. The bat stick, the shovel, and you're dead because you hurt the little princess, right? By the way, my parents-in-law are extremely cool folks. I love them, so I really hope yours are cool guys as well. Sorry, cool people. English is not my mother tongue. And yeah, the promise/threat is one day this will be default. So better get prepared, better add this, all add options and stuff, basically. Yeah, among this needed 5. Yeah, we've been here. And when migrating your stuff, keep one thing in your mind. There are no the same 2 applications under the sun, right? So your mileage might vary, basically. Your migration might not be the same as the ones I had. And yeah, if you want to see like a trivial migration, you can go to my GitHub account, and we have a simple application in there. And what this application does, I mean, I couldn't show the real code because NDA and stuff, so I like kind of extracted the issues I saw, I experienced, so here they are for you. So we have a simple application. What it does, like it does what most of our applications does. Like it's not so smart. Anyway, we have 2 Pojos, Alice and Bob. They're children of John. We want to serialize them to XML, and then we want to encrypt them, right, to base 64. Of course, everybody in the room knows like base 64 is not encryption. And then we want to take a deep look into John's name. So let's take a look into this create base 64 method. Yeah, so we're using sunmisc base 64 encoder. And for this deep look into what we do, again, we summon the demons of deep reflection, because we are setting set accessible true on the value field, being a value field from class string. And then we want to get the content and see we are casting it to character array, basically, because we want to get it printed. Yeah, so let's make it run, right? So this okay, I should have it like Java 8. Yeah, this is the command. It's in the README file, so we can find it. Yeah, and this is the output, basically. See, so we have John and John's children, Alice, John Doty, and Bob Johnson, and then we serialize them to XML. Then we encrypted John to base 64, and the actual character array is JOHN. I mean, this is the expected output in Java 8. Let's switch to Java 9. Sorry, Java 9, and it worked again. But one thing we didn't notice when it came to Java 8 is there was this warning that sunmisc and sunmisc base 64 encoder is a proprietary API and might get removed in the future. And in fact, it was removed. In Java 9, it's no more. That's why we had to replace it just in order to make the code compile. And as you can see, we have no more JOHN. We have these numbers. I mean, we get the actual bytes. So let's dive into the code. And this is how the code looks like right now. See, there's no character array. Right, this byte array, bloody awesome compact strings, which can save you tons of money, really. And there's a new class to be called to get base 64. And there's one more thing, because we're still committing this crime. Yeah. So let's go to this build Gradle and see. When I remove this add opens, that I'm opening Java lang package from Java base module to everything I have in a class path. Let's stick to this parents-in-law option, and let's see what happens. So let's Gradle clean and run it. I mean clean just to be sure. Yeah, and see then there is this extended warning. So it says you have illegal reflective access, and this is exactly the line up.java line 63. And when we check this line, yeah, this is the line, exactly, 63. See? So it tells you that they're violating the OOP principles, more or less. Yeah, and to get rid of this warning, okay, I know this is bad, because what you should do in the first place, you should refactor this code, right? You should make the campground cleaner. But in case you can't, because I don't know, JPA happens or something, this is what you can do. You can say, again, add opens that we're opening from Java base module, Java lang package to everything we have in a class path. Like all unnamed means class path, basically. And yeah, to make it work, we had to do one more thing. We had to add these Java XML modules, because if we don't, then imports like this won't work, because these classes are still present in Java 9 and 10, but they are not enabled by default. So to enable them in Java 9 and 10, and if you have anything started from Java X, odds are you want to do this in like Java 9 and 10 before, then you have to add this add modules Java XML bind, for example, or you can go like everything and se.ee, basically. Okay, then there's the time you want to migrate to Java 11, I guess. Java 11, yeah, let's run it. And you see the output didn't change. It's still the same. However, we had to change one thing, being the this build file, as I told you, because there are these modules. I mean, Java Standard Edition .enterprise edition module got out, so we had to add explicit dependencies, like in Gradle or Maven. So here they are coming from like JCenter or Maven Central or whatever. So we have them because they got decoupled, they got extracted, excluded, whatever the best description in English is. And that's it. I mean, these are the simple steps. And yeah, I just want to get back to these reasons why we should convince first ourselves, then the people we work with, and then like the bosses and the money keepers. I mean, these dragons, you know, they always lay of these piles of gold, right? So give me some gold so I can migrate the Java for you. Okay, so I have another simple application for that, and let me close this one. Sorry, it's this. I'll exit this presentation mode. I'm not an expert of presentation mode. Usually I'm just a developer, not a presenter, but anyway. Okay, so here we are. This application does something. I'm not going to tell you what it does, and I do it intentionally for a minute. So what we can do, of course, we set the maximum amount of memory. Then we want to log everything related to GC. So we say GC asterisk, and we want to use this new unified logging stuff, and we want to log everything as debug to this tmp GC log file. And can you tell me what's wrong with such declaration? TMP, who said TMP? Someone said the TMP. Okay. I still have some jellies. Exactly. Don't log stuff to TMP. Sorry, it's empty now. Don't log stuff to... almost there. Don't log stuff to TMP, because after you remove it, it might vanish, basically. And you want to log UCT time, uptime, thread ID, and so on. Anyway, so we ran this application, and we discover what happened. And then I can open such a log, and it reads like this. It's very nice. It can show you everything. See the first GC pause, then more GC pauses, more intristics and internal stuff, and so the story goes. And we go to the very end, see? And the program was running for like 22 seconds, and we have almost 200,000 lines. So it's a true debug, yeah? It will last for a few weekends. Yeah. But so we can read everything that happened to this garbage collector. But let's say you don't want to get into this. So there's this, I mean, there are more things I've used here. And see, this is like using this start flight recording. So we're recording how this application performs throughout the flight to this black box. And we also call this application with this argument. What is your password, baby? Yeah, and this is the Java mission control. Yeah, so this is this version 7.1 and stuff. And here is this recording being opened. And see, there are some, yeah, this is a result of so-called automated analysis results once you open this file that got recorded. And you see some red exclamation marks. And there's something wrong with the memory. See, and the byte array got allocated, like total allocation was 1.64 gigabytes. And we can also take a look that there were issues with garbage collections. Of course, we have G1, as you can see. And the most interesting thing is here, it says threads allocating, and it tells us that the app producer, meaning most likely the producer thread, was allocating like crazy. So this is like Okay, your application runs out of memory, basically. It has heavy GC issues. It was low physical memory, and the producer thread allocated most of the stuff. And the thing allocated was this Java byte array. Okay, and we can even get like the line here, I guess. No, it's just producer run. Okay, and there's even more. The thing is so bloody good. Take a look at here. It says that there was something wrong with the passwords and Java arguments, because you shouldn't pass passwords as Java arguments, basically as arguments, because bash history and stuff. So it's good habit plus mem dumping and stuff. So it's that good. So let's go back to the code of this application. Just app here and sorry, out of jellies. But can anyone tell me what's wrong with this code? We have two threads, right? We have two threads, one named consumer, one named producer. They both started. And what's the issue?
Infinite memory allocation?
Yeah, that's one thing. But the thing is, the consumer takes 100 milliseconds to consume these 3 megabytes, whereas the producer produces a new piece of data every 50 milliseconds. That's why effectively we get out of memory, basically. And see, so now we see that in the source code. It's a very simple application, but we can even analyze the application like in a production. We can profile the application in a production with really low overhead. And one of the things we also did using this on Monday was we compared G1 with Shenandoah and ZGC, which are new garbage collectors. ZGC got introduced to Java 11, and it's developed since there by Oracle. Red Hat introduced Shenandoah in Java 12, but guess what? They are backporting it. That's cool, right? So we compared, what we did, we compared G1, and the G1, the longest pause took 150 milliseconds, and then we compared with Shenandoah, which is 1 millisecond, and then we compared with ZGC, which is 1 millisecond. That's all, right? Something smells here. Do you know the smell? Money. Really? That's why we should also convince our bosses to switch to Java 11 and beyond. Because this is the smell of the money. They're not going to burn this money because we're going to have so small, so short stop-the-world pauses, basically. I also told you that we can have this JShell, so we can have JShell scripts. So let's go for this JShell script. We can have like a cd src main Java, yeah. So I have like a cat make var JShell, and it looks like more or less like Java, except this one command which tells to exit, and we can run this finally. Finally we have like a script execution using this REPL. See, it's going to work. Yeah, it worked. And what we can also do is see this file, java.script. It has this asterisk, right? It has this executable flag set. Let me cut it for you. It's JavaScript. Does it look familiar? Can you spot the difference? Yeah, it's the shebang. So what we can do now using Java, we can do this. Java.script. Boom, and it worked. See, now we can write scripts in Java. Self-executable scripts, basically. Isn't that cool? And yeah, I'm using here this this stuff, so it's more aware of these Docker constraints, for example, and stuff. Let's go back to the slides. If you want to have like more not so trivial migration, who knows this pet shop? Spring's Pet Shop. Yeah, so there's a nice link to a blog post describing how we can do this as a migration kata or something, so we can train migrating like something artificial before diving to real stuff. Okay, so if you like this talk, we can have a training on Java, because there's much more in Java 11 to explore, like the Unicode emojis. Yeah, and Helle bedankt, merci beaucoup, vielen Dank, thanks a lot for attending this talk, but we are not quite done yet. I'd like to do one thing. I want to ask you, my friends, to provide always, and for every speaker, not just me and not here this session, not only DevOps, for every speaker, please provide your feedback, people, because it values, really, because we are here not only to teach, but also to learn and to share the knowledge. Like usually I'm that part of the audience, okay? But I decided I've learned something, so I just in this very part of the room, so I want to learn also from you how it works and so on. So provide your feedback in any form. I even accept paper forms. And yeah, for those of you who are watching this online, like now or later, you can use this. Form to provide your feedback, anonymous one, if you don't want to tweet me or anything like this. And this is the link of the slides. This is my Twitter account. We have 1 minute for questions if you have any. There's a question, yeah. How about Spring and GPA? Sorry, we had only 1 minute, sorry. JPA, yeah. Another question. It's doable, yeah. Like one of the slides here exactly is about this, right? This is the migration, like Spring migration, you can get it here. Okay, sorry, the screen is red, it shows time's up. Once more, thank you very much for attending this talk. Enjoy DevOps and share your knowledge. Thanks. Dziękuję bardzo.